Welcome to Web Handling. My name is Dave Roisum. We continue our tour of what may matter by talking about web routing. I am occasionally asked to review a new or existing design for web routing. This narrow review assignment would not consider perhaps the most important aspects of web handling design, such as roller geometries and precision, control range and precisions, winding method and control range, and many other concerns. Narrowly interpreted, routing is the arrangement, order, or sequence of rollers in this case. Another useful definition is commutative, which means that order does not matter. Examples from algebra include addition and multiplication that are both commutative. However, here we are not interested in algebra. Here we are interested in whether web processes are commutative. Here we are interested whether web handling is commutative. Let us begin with web processes that are almost never commutative. An example is coding followed by drawing would give very different results than drawing followed by coding. There are processes that might seem to be commutative, and sometimes they are. For example, it is common to cool prior to winding. Why? Will not the web eventually cool in a wound roll? It sure will. It may take hours to weeks in the case of large master rolls of metal. However, if properties such as tackiness might cause layers to block, then it might be wise to cool first. If properties such as thermal contraction could cause the stresses in a wound roll to skyrocket, then it might be wise to cool first. You need to know for sure. If you cool when you didn't need to, you cost your company money. If you don't cool when you should have, you cost your company even more money. Another risky example is certain Tripex laminations that involve low-tack adhesives, such as found in many packaging materials. These adhesives act like grease until they cure, perhaps a couple days later. You might be able to tolerate one layer of glue, without type 2 telescoping, cure, then safely add a second layer of grease. However, filling the wound roll with 2 layers of uncured grease may shoot the wound roll into the aisleway. While web processing is seldom commutative, web handling usually is. It usually matters not whether you route a web over, under, over, under, well, you get the idea. Of course, there are many practical considerations to routing, but those may be above and beyond strict web handling. Two seldom discussed cases involve sensors. As we learned in Web 101, it usually does not matter where in a drive zone you put a load cell, because the tension signal moves at the speed of sound in the material, so response is not affected. On the other hand, it matters a lot where you put a guide sensor, because that signal moves at web speed. Putting the sensor anywhere except for right at the moving roller just adds to the delay in the control system and results in degradation of control response. What matters in web handling always was also covered in the 10 Commandments of Good Web Machine Design, the section in Web 101. You want the fewest rollers possible, including idler rollers. You also need to have sufficient wrap angles on driven and undriven rollers to transmit the required tension difference without a loss of traction. To this, we add just a couple of final observations. First, it is usually best that webs be routed overhead, because operators walking over webs will just add to the contamination. Second, if operator access or inspection is desired, a vertical or slightly slanted from vertical run is often best. Thank you so very much for watching this module and my plant practical video clips. Stay tuned as we continue our tour of what matters in web handling.